I hope that there will not be a problem in this question. Uh, let's proceed to the next question. So in this question, it is said that a chef is making n cookies for n kids. Okay, like there are n kids. Okay, and there are m cookies. So I need to distribute these m cookies into n people. So, uh, and I've been also told that if suppose the number of cookies, like if I can't distribute this number of cookies into n people equally, so I can either destroy a certain number of cookies so that I can distribute it to n people, or I can add a certain number of cookies so that I can distribute it to n people. Okay, so first of all, I will check like whether this m cookies can be equally distributed into n people or not. Like suppose if n modulo and it is equals to 0 or not. So if it is 0, so I can say that uh, I can distribute these m cookies into n people. So in that case, like I don't need to destroy any cookie, or neither like nor I need to add any cookie. So eventually the time taken to distribute it will actually be 0, because I know I've been told in this question that to destroy one cookie or to make one cookie, it will take 1 second. Okay, so if I'm not destroying any cookie or making a cookie, so it will not take any time, so the answer will be 0 in that case. Now suppose if I have a value m which is not divisible by n, like suppose the n is 5 and the m is 17. So you can see clearly that this m cookies can't be divisible, they can't be equal distributed into n number of people. So in this case, I need to either destroy some amount of cookies or add some amount of cookies. So like how many cookies can I destroy in order to make it equally like distributable? Like suppose there are 17 cookies. So how many cookies do I need to destroy so that I can distribute into five people? Like it would be suppose 17. So if I destroy two cookies, it would give me 15, and I can easily distribute these 15 cookies into n people, like five people. Like each will have three cookies each, and two and a time will and a time taken to destroy these two cookies will be 2 seconds. Similarly, there is 17 cookies. Now if I make three cookies more, I will have 20 cookies. Now again, I can distribute this 20 cookies into five people. Like if each person has four cookies, so then I can easily distribute it to. I can easily have the total number of cookies as 20. And in this case, the time that will be taken will be 3 seconds. Now I have to find the minimum number of time that is possible, so that I can distribute these m cookies into n people. So you can see clearly from these two numbers that the minimum of these two numbers will be how much? 2. So that should be my answer. So this is how the question says. So first of all, if I have, so if this m is not divisible by n, so there can be two possibilities. First of all, this m is greater than n, and this m is less than n. If m is greater than n, so that means the number of cookies is more. So in that case, I can either destroy the cookie or I can add on cookie. Okay. And in either case, I'll get a time. Okay. So, uh, so first of all, I need to find how many cookies can I destroy, so that it can reach a number which would be divisible by n. So that would be like simply m modulo n, isn't it? Yeah, right. So like, okay, so if uh, the number of cookies that I need to destroy would be how much? M modulo n. That many number of cookies I need to destroy so that it can become a multiple of n. Similarly, if suppose I have to add some cookies, so the number of cookies which I can add would be n minus rem, where rem is basically m modulo n. So, and you know that the number of cookies that I will destroy and the number of cookies I will add will basically take 1 second each. So, if suppose I destroy 2 cookies, it will give me 2 seconds. If I add 3 cookies, it will give me 3 seconds. So, eventually, the minimum of these two will give me the answer as the minimum time taken. Okay, this is the condition for m greater than n. Okay, the number of cookies is greater than the number of people. Now, suppose the number of people are more than the number of cookies. Like suppose if n is 4 and m is 1. So in this case, you can see that I can't just destroy a cookie, because if I destroy a cookie, eventually like neither of the people will get a cookie. So in that case, I always have to add cookies so that I can distribute these cookies into this n number of people. So in this case, the answer will just simply be n minus n. Okay. So in this case, the answer would be minimum of rem and n minus rem. And in this case, the answer will be just n minus rem. Fine. Yeah. N minus m. Oh yeah, it is also fine. So like let's look at the code. Like so if the value of m, so basically if suppose if m is divisible by n, so in that case I'll just simply write the answer is 0, because I don't need to destroy or make any cookie. Now it is not divisible. So in that case, I'll find the remainder. So the if the number of cookies is more than the number of people, so the answer will be just minimum of n minus rem and rem. And if the number of people is more than the number of cookies, so the answer will be n minus rem. So then I am just printing the answer. So that is my answer. Fine. So like, is there any problem in this question? Like, if you have, you can ask. Okay. Okay, so let's proceed to the next question. So before us going to the next question, say how many have been able to solve this? Okay, fine. So like, let's proceed to this question. So this question says that I've been given up to find the two up to basically print two permutations of length n, where like up to basically suppose there is one permutation, suppose a and b. So A will have sub numbers, suppose A1, A2, and so on. It will have numbers B1, B2. Now I'll find the absolute differences of each A of I and B of I, like uh, A of 1 minus B of 1, A of 2 minus of B of 2, and so on up to n. Like how many number of elements will be present in this two arrays. Okay. So now after finding these differences, I need to find the minimum of all these values. So suppose the minimum, suppose I got suppose as k. So this is a number that I'll get for a particular type of permutation. Like suppose like this, a1 a3 dot an, and similarly b3 dot bn. Now I've been asked to arrange these two permutations in such a way that I can maximize this value of k. Like I have to make this value of k such that it will be the maximum possible value for this particular set of numbers. Okay. So like suppose I've been given the value of 5. Okay. Sorry for the interruption. Uh, okay, so let's proceed to the question. So suppose I've been given a value n. So I can just write one permutation as 1, 2, 3, 4, 5. So now I need to arrange the second array in such a way that the differences should be as max as possible. So one of the way I can do is that I'll basically take this last n by 2 numbers of this array in the beginning. Like suppose this is 1, 2, 3, 4, 5 now. So I can, if I write this array like this, 4, 5, 1, 2, 3. So in this case you can see that the difference between these two numbers will be 3. The difference between these two numbers will be 3. This will give me 2, 2 and 2. Okay. And the minimum of all these numbers will be 2. Now if you try any other combinations, like even if you use like 3, 4, then also you will get the answer as 2. But other than these two combinations, all the answer will be either like 0 or you will give me 1. So this is the maximum number of, this is the maximum the distance can be possible. So for doing this, so basically what I'm doing is that I'm taking a first array as 1 to n, like the first n natural numbers from 1 to n, and the second array will have the first two elements will be the like n by 2. Suppose if I say k equals to C log n by 2, so the first n by 2 numbers in the second array would be from k plus 1 to n, and the rest of the elements would be from 1 to k. This way I can arrange, or I can arrange from like k to n and the other elements from 1 to k minus 1. So by arranging these two ways, second array, so in that case you can see that I can get the maximum number of difference, like the maximum distance possible. So like let's look at the code. So for value of 1, like the number of elements is 1, I'll just simply write 1 and 1. Now if suppose it is not 1, so first of all I will find the value of k. So the first value of k first array, I'll just print the values from 1 to n, like 1 to n. Second value, in the second array, I'll just write like I'll first of all take the last two numbers. So what is doing that? Suppose the value of I is 0. So 0 plus k. K was how much? Suppose I'm taking this example only. Suppose n is 5. So the k would give me 3. So I will basically write from, so for the first two numbers will be 4 and 5. The other two numbers will be 1, 2 and 3. Like if we try for this combination. And if we look for this combination also, like if I write 3, 4 and 5, and the rest of the elements as 1 and 2. In both the cases, I'll get this number as, I'll get the minimum value. The distance will be 2. Okay, so this is what I've done. So in this case, like I basically have stored this value. So the last two numbers of this particular array will be stored in the first two values, and then the rest of the elements will be the first two elements of this particular array. Fine. N plus one. Oh yeah, yeah. That is what it. Fine. So like, is this clear? Okay, fine. So the rest of the questions will be like said by Sib. So like I'm stopping sharing the screen for now.
Okay, so hello everyone. Let us start with the next question. So what we have here is that in the question we are defining f of x as the largest divisor of x other than x itself. Okay, so in case of 12, Asha, like before starting, like how many have you solved it? Can you raise your hands? Like solved it or attempted it at least? Okay. So Shaunak, you may write your approach in the chat box, and like after seeing the question, I'll come and check it. Okay, so what we have here is that f of x is defined as the largest divisor of x other than x itself. So we have f of 12 as 6, f of 7 as 1. So yeah, and after that, what we are told is that we have an integer k, and we have to find the sum of all numbers n, such that f of n is equals to k. Okay, so yeah, the question is pretty short. K into sum of primes till k. Yeah, right. That is the crux of this question. Uh, so let us take a test case from here. Okay, or we can say we take 7. Okay, so now if we are to find that how many numbers are there which have like 7 as their largest divisor after that number. So what so if we actually think about this, 7 itself is a prime number, right? So if I think of 2 into 7, so 2 into 7, that's 14, right? uh, so in case of 14, other than 14, the greatest divisor will be 7 itself. And then if we think about 3 into 7, in this case as well, like after 14, sorry, after 21, the largest divisor would be 7 itself, right? because like we have two potential divisors, 3 and 7. So among 3 and 7, the largest will be 7, obviously. Now if we come to 4 into 7, so in this case can we say ki, 7 will be the largest? No, right? Obviously no, because 4, we can like further subdivide 4 into 2 into 2, and like if we just take out 1 2, then we have 2 into 7 remaining, right? And 2 into 7 can be a divisor of 4 into 7, which is 28. So as we know that 14 is a divisor of 28, and it is greater than 7. So of course we need to rule this one out, so this will not be eligible as a potential sum. And now if we go about 5 into 7, so again in this case we can again say that 7 would be the greatest. And now let us say we go for 7 into 7. Again both of these are same, so yeah. But now let us say we go to the uh, okay, now if you go to 8 into 7, so can I say ki 7 would be the greatest divisor other than the number 8 into 7, that is 56? Obviously no, right? We can just see here that 8 is a is greater. Like yeah, there can be other ones as well, like for 56, 28 is the greatest divisor actually. But yeah, we can be clear that if there is any number greater than 7 and we are multiplying that with 7, then there is always some possible value of the divisor which could be greater than 7 itself. So after 7 there is no point in continuing this, right? And if we notice here that there we are noticing a pattern, then in case another multiple is a prime number and that prime number is less than or equal to 7, in that case we always have this condition to be true. Okay, the f of n will always give us 7, right? So like this is just one example. You can dry run it by yourself on a rough sheet with various different numbers, but you will always end up noticing this pattern. So now what we have to do is that we need to provide the sum of all these numbers, right? So like we can do that in various ways. You can just multiply them and keep adding them, or you can just add all the prime numbers at first and then you can multiply that with the given number that you have. uh, so the brute force, like this question, like if you just think about it a little, the approach will be clear. Like as Shaunak has said here, uh, question is not clear to me. Acha, okay, I'll go through the question once more. Okay, so what we have here is that we are defining f of x as the largest divisor of x other than x itself. Okay, so like if you think of let's say 64. Okay, so what will be f of 64? So the largest divisor of 64 other than 64 itself, it's 32, right? So this is the definition of f of x. I hope this is clear to you. It is like very simple. And then what we have is that we are given an integer k and we need to find the sum of all n, like all numbers which have f of n equals to k, right? So yeah, there was an example that I gave on the whiteboard, and also here we can see, like let us go for this test case 3. Okay, so if we go for 6 and for 9, for 6 the greatest divisor other than 6 would obviously be 3, right? Because 6 can be written as 3 into 2, and like so 3 is a divisor, 2 is a divisor, and the greatest among them is 3 other than 6. And also in case of 9, the total divisors of 9 are 1 3 and 9. So if we remove 9, the greatest divisor is 3 itself. So for 6 and 9 we have f of n as 3, right? So we just take the sum of 6 and 9, which will give us 15. So I hope like the question is clear to you now. Chris? Yeah. Okay. Arnab, I hope the question is clear to you. Like, if there are any further doubts, you can like write that in the chat box. Okay. Yeah, like it is a seed-based approach only. But yeah, there is another small optimization that you have to do. Yeah. Okay. So yeah, like the basic concept that you have said here is that k into the sum of primes till k. That is absolutely correct. So okay, let's see what we have done here. So firstly, what we have taken is boolean vector is prime. Okay, uh, and then we have a vector of primes, and like this vector will basically store the prime numbers. Okay, and then this is the prime sum. Like I hope you are all familiar with prefix sum. So basically, it is something like that only. Like up to us, like prime sum of I basically denotes the sum of all primes till the number I. Okay. So what we are doing is that we are pre-computing the sum in order to reduce our, in order to let's say optimize our time complexity. Okay, so like this is the boilerplate code for Ferratosthenes. If I explain it, then this meeting will be like unnecessarily elongated. So it's better that you guys go about on different online articles or different videos on YouTube. It is a very simple concept. You can learn it. But like if you still get your doubts, there are always the mentorship groups and like our recursion group. Yeah, you can just mention that in any other group and we'll be happy to help you out. But right now in this meeting I'm not talking about this sieve apparatus things. You can just consider it to be a method which could very efficiently calculate uh, and mark the prime numbers to a particular limit. And in this case, we are taking the limit to be 10 to the power 6 because our k can be as big as 10 to the power 6. Okay. Okay. So now let's get into this. So we are taking the input of test cases, and after that, we are running the sieve of Eratosthenes. So once we run this, as because this vectors are global, so like we just need to run this once for our for all test cases. We don't need to run it again and again. So like, and since these are global variables, we can access them from any scope basically. So what we do next is that we take input of k, and after that we have declared a sum of primes, so that is initialized to 0 at first, and then we are checking like if our number is prime. Okay, if like the number is prime itself, then what we do is that we simply return the sum of primes till that particular number k. Okay, and now let us say if it is not prime, so what should we do? In case the number is not prime, then we need to like find the smallest prime factor of that number. Okay, we need to find the smallest prime factor of that number, and we need to provide the sum up to that smallest prime factor. Okay, so that's the basic step. And after that, what we do is that simply the sum of primes multiplied by k, that is what we return as the answer. Okay, so yeah, let's go through this part once. Ki, why are we doing this? So let us say that we have 35. So 35 is our k, and 35 is represent can be written as 5 into 7. So in this case, like if you think, if we have 2 into 5 into 7. So like this part is 35, right? And we are multiplying this with 2. So if we try to find the greatest divisor of this number, like 2 into 5 into 7, other than this number itself, then it's definitely 5 into 7, right? Similarly, we can change this 2 with 3 and then with 5. But let us say the next prime number that we encounter will be 7. So 7 into 5 into 7. So like will we be able to say that in this case as well, we will have like 35 as the value, like as the required value? No, right? Because like if you think about this, if you just remove 5 from here, right? So in that case you have 49. 7 into 7 will give you 49. So which is greater than 35, right? Which is greater than 35, but it is a divisor of this number, 7 into 7 into 5. So it is a divisor of this number and it is greater than 35. So in this case our condition breaks. Okay, so what we have to do is that in any number we have to like find the smallest prime factor of it, and then we have to like we have to return the sum up to that prime number multiplied with k. Okay, so this is what we are doing. And okay, so let us run this code. It's successfully executed, and now let us submit it. Okay, so as you can see, this approach works. And yeah, about like Shaunak, like as you said, the sieve wasn't working. Maybe the issue was that see, like in case let us say the number is big, like the test case is defined such that there are only large prime numbers. Okay, let us say prime numbers are greater than 10 to the power 5. So in that case, uh, there might be some problem with, like maybe you are iterating through the numbers to find the smallest prime, or maybe you are iterating through the sieve to check for it, or like maybe you are not implementing this prime sum array, because of which you have to iterate to find the sum. Maybe there is some problem like that, so you can discuss that in our group, or maybe in your mentorship group, wherever you feel comfortable. And yeah, we can like talk about that, why are you getting that TLE error, or uh, whatever error you are getting once you share your code. So I hope this question is clear to all of you. Thank you for joining us. We would be discussing these questions only, and for any further doubts, your mentorship groups are always open. Okay, thank you guys. Bye bye.